Okay, Chloe, we're gonna be running with the class. This is exactly what we did. I will try to record class, I guess, lessons, at least for this week so that you can catch up on it. But yeah, I think being absent is going to put us in a very tough situation. Not impossible, but does require lots of effort to catch up. So chapter 2.3 is essentially everything that we have done, 2.2 and on. It's just to show you how to do an example question. It may seem a little bit challenging and I may go a little fast, so please feel free to rewatch the videos. Okay, so don't worry about factor by grouping. I'm going to try to show you this question as you would normally do if you got it on a test. Okay, question says to solve giving an equation, which means what's x? What value of x makes this true? The only way we know so far how to solve for x is when you make one side equal to a 0 and the other side is a bunch of factored binomials. Okay, and so let's do it. I'm going to bring everything to one side. Subtract 3x squared cubed and subtract 3x cubed. This becomes x cubed. Subtract 2x squared, subtract 2x squared. Add x and add x. And then add a 4, add a 4. Here's my new function. And if I could solve the x values that make this true, then I have automatically found the x's that make the above true. That's the logic. Here we go. Seeing as how the last term is a 9, that's the constant term. By, this is 2.2, integral 0 theorem. Okay. I know that the factor is going to be in the form of x minus b, and the b value that is going to be a part of the factor must be a factor of the constant term. So it's going to be either plus minus 1 with a plus minus 9. It could be a plus minus 3. So 1 times 9 gives me a 9, 3 times 3 gives me a 9, all the possibilities of multiples of 9, so factors of 9. Okay, so I'm going to first test the easiest numbers. I'm going to test by factor theorem. If I plug in a 1 and the answer does equal to a 0, then I know that I can factor it nicely. I'll say it one more time. If x minus 1 is a factor of the original equation, if I plug in x equals 1, it should make the entire equation equal to 0. That's part of chapter 2.2 as well. Okay. So I'm going to test it. So originally, so this is 1 cubed minus 1 squared minus 9 times 1 plus 9. That is equal to 1 minus 1 minus 9 plus 9. That does equal a 0. I got it. If it's a factor, I can divide it without worrying about a remainder. And so I will do that by synthetic, which is easier to me. 1, -1, -9, and 9. Drop the first number down, multiply, add, multiply, add, multiply, and add. Therefore, my new function is going to be x minus 1 and x squared plus a 0x minus 9 equals a 0. And of course, I don't have to write that down. But if you have an eye for this, you will notice that the second bracket is actually a difference of squares. And we can factor that further. It's going to be a +3 and a -3. What does that mean? That means to make this equation true, x must be either a 1, it must be either a -3, or it must be either a +3. And if 1, -3, or 3 makes this equation a 0, then 1, -3, and 3 also makes this left side equal to that right side. We have solved the question. Okay. I'm going to do this again for the second example. And for the third example, the paper on the back, what I mean by that is example 3, the long example answer question on the back of this page. It's particularly hard. And I think we can wait for that until maybe lesson 2.6 and 2.4. I am going to take some time to do the bottom question here. And you can try to do some textbook questions off of that, okay? So here's an equation that says solve. Once again, I need to find all the x values that make this statement true. And I recommend try common factoring to make your life easier. So I will. I have. I noticed that -4 is a common factor, and an x is also a common factor. Leaving these four terms as x cubed, positive 6x squared, positive 9x, and a positive 2. Okay. So this is a bracket on its own, which is great. But now this is a cubic, and I know that if I factor it nicely, it should turn into something like that. All right, here we go. I am going to, by integral 0 theorem, if x minus b is a factor, that means b has to be a ±1 or a ±2. Now I'm going to test it. I'm only going to test this part because this is the polynomial that I want to actually factor. I don't need to worry about the -4x. So let's try it. Test. By factor theorem, if 1, -1, 2, or -2 does divide this nicely, then if I plug it in, the answer should be a 0. Yeah, a second. Give me a second. Let me pause this video for a little bit. How do I pause? Okay, back to recording. Sorry, I was interrupted, although the video might not show that. Okay, so let's get back to it. So by factor theorem, I'm going to test if 1 will make this gray portion a 0. So it's 1 cubed plus 6 times 1 squared is 6 plus 9 plus 2. That is not a 0. I will test, 1 second, -3. And then -1 cubed. And then -1 squared times 6 is +6. -1 times 9 is 9, and plus 2. That is not going to be 0. Let's try 2. 2 cubed plus 6 times 2 squared plus 9 times 2 plus 2. That's an 8 plus 24. Yeah, that's too many pluses. Not a 0. -2 cubed plus 6 times -2 squared plus 9 times -2 plus 2. -8. Positive 24 minus 18 plus 2. That is going to equal a 0. Yay. So this, I'm going to divide using the root x plus 2. That's going to be my root. 1, 6, 9, 2, 1, 2, 4, -8, 1, -2. Take your time with that. I'm just doing it really fast so that I don't waste your time watching a video. Do synthetic division, and you will see that this is going to be equal to -4x, x plus 2, x squared plus 4x plus 1 equals a 0. That's it. But you will see that this is a root, that's a root, and this isn't factorable. So does that mean there are no zeros? Well, you don't know that. What you're going to do to confirm is check using quadratic formula, where a value is a 1, b value is a 4, and c value is a 1. You're going to plug that in to see if x could be a intercept with -b plus minus square root b squared minus 4ac over 2a. And you will find that yes, this still has roots. The final answer, I'm not going to do it for you. I want you to try it by doing quadratic formula. The roots are going to be 0 from here. It's going to be -2 from here. X could, using the quadratic formula, also be -2 plus root 3 or -2 minus root 3. There are 4 zeros here. And going further, if I had to graph it, it would look something like this, like something like that. Okay, not that it's necessary, but give this a shot. After this, the class was responsible for a sort of problem-solving in-class assignment. It was a single question, but quite long, which finished with them graphing, just like I did here. So hope you can use this to review. Please take everything with a grain of salt and not fall behind. I hope you're doing, I guess, having fun. I was told that it was vacation. And yeah, see you when you get back. Bye.